Okay, number 5 says to solve a triangle. They only give me that A is 5, B is 7, and C is 42. I just drew a triangle and I label it A, B, and C. So I'm missing little c and I'm missing A, B, and C. I looked that law of, I am super sorry, I don't know why I wrote cosine right here. It's supposed to be law of cosines. This is law of cosines. C, I have A, B, and angle C. So I'm going to use this one to solve for C. So to solve for C, I'm going to take the square root of A plus B minus 2 times A plus B cosine of 42 degrees. Make sure it's in degrees, make sure it's in degrees, or calculate it in degrees. From here, I get that C is 4.7. Then I also love cosines. To solve for A, I'm going to do cosine inverse. And we are going to do B, which is 7 squared. 4.7 squared minus 5 squared over 2BC. I'm using this formula with the numbers I have over here. I put this in the calculator and I get 45.5 degrees. I add those two, subtract from 180, and I get 92.5 degrees. Okay, this is the second part of the question number 5. This one they give me all the sides, 5, 7, and 10. Sorry, I flipped them there, but it's okay. So I'm going to solve for A. I'm going to solve for angle A. So I'm going to do A equals cosine inverse. I'm going to do B, and B is 7. Plus C is 10 minus A, which is 5. Over 2 times 7 times 10. Okay, I plug that into my calculator and I get that A is 27.7 degrees. I'm going to do the same thing, go to my calculator, cosine inverse, but now it's A, which is 5, plus 10 squared minus 7 squared over 2 times 5 times 10. Just following the formula, I'm just following the formula. From here, I get 40.5. I add those two, subtract from 180, and I get 111. So now we are moving on into the vectors. So we're adding and subtracting vectors. So we just combine my terms. So I got 2i plus 5j plus negative 3i plus 7j. So I just combine my terms. 2 minus 3 will be negative 1i. 5 plus 7 will be 12j. I just put those little hats on the top because they're vectors. Those you don't have to, that's okay. Now we got 2i plus 5j, but now it's a minus. I'm going to be very careful. I'm going to put a parentheses. I need to put a parentheses because I need to distribute the negative. Be very, very, very careful. So I got 2i plus 5j plus 3i minus 7j. So that would be 5i minus 2j. Finding my terms. Next one, I got b. So now I got negative 3i plus 7j minus 2i plus 5j. But just like before, I'm going to distribute the negative. So it's going to become minus 2i minus 5j. So negative 3, negative 2 becomes negative 5i. 7 minus 5 becomes positive 2j. Next one, we need to distribute the 3. On this one, we need to distribute the 3. I got 3 negative I minus 6j plus 2 negative 3i plus 7j. Be very careful, we need to distribute first. So it's going to become negative 3i minus 18j plus, well, negative 6i plus 14j. So negative 3, negative 6 will be negative 9i. And then we do negative 18j plus 14j, and we need negative 4j. Next one, 3 times negative 3i plus 7j minus 4, negative I minus 6j. We gotta distribute. So 3, negative 3 will be negative 9i. 3 times 7 will be 21j. Negative 4 times 1 will be positive 4i. Positive 4 times, no, negative 4 times negative 6 is a positive 24j. And then we combine that term. So negative 9 plus 4, negative 5i. And then we got 21 plus 24. That will give me 45j. Okay, the next one will be unit vector. So unit vector, you have the v over the magnitude. And remember the magnitude, you squared x, you square y, you square root of that. So first, let's find the magnitude of v. So we're going to do 3 squared plus negative 4 squared. That gives me 9 plus 16. That's the square root of 25. So it gives me 5. So my unit vector will be 3 over the square root of 5i minus no. Not square root of 5. So let me write it again. It will be 3 over 5i minus 4 over 5j. Okay, next one. Unit vector, 3 squared plus negative 2 squared, 9 plus 4. 13 is not a perfect square, so say square root of 13. So my unit vector will be 3 over square root of 13i minus 2 over the square root of 13j. And those are my unit vectors. Okay, number A says to determine if two vectors are parallel, orthogonal, or neither. This is a formula to finding the angle. But to determine if two vectors are orthogonal, the dot product equals 0. So if I do the dot product and automatically they equal 0, they're orthogonal. If it is not equal 0, then I need to find the magnitude of u and the magnitude of v. Okay? If this right here equals to negative 1 or to positive 1, the vectors are parallel. If I get anything else, vectors are not orthogonal and they're not perpendicular either. They're not parallel or orthogonal. So let's get started. So you always want to get started with the unit. You always want to get started with the dot product. So what is dot product? You multiply the x values, you multiply the y values, and you add them. So we're going to do negative 2 times negative 6 plus 3 times 9. So from here, I get 12 plus 27, which is 39. You see, I didn't get 0. I keep on going. I'm going to get the magnitude of v. So I'm going to do negative 2 squared plus 3 squared. That would be 4 plus 9. I get square root of 13. I'm going to get the magnitude of w. Magnitude of w will be negative 6 squared plus 9 squared. That is 36 plus 81, and that gives me square root of 117. So now I'm going to do this formula right here, which will be 39 over the square root of 13 times the square root of 117. If you put that in the calculator, it's going to give me positive 1. So my two vectors are parallel. Okay, my two vectors are parallel. The difference between A and B is that instead of a plus, they have a minus. So sorry, I was copying the wrong one. So let's look at the dot product. So negative 2 times negative 6 plus 3 times negative 9. So now in this case, I got 12 minus 27, which gives me negative 15. Okay, and now it gives me negative 15. So then I get the magnitude. In this case, it's going to be the same thing as this one, because we have negative 2 squared plus 3 squared, 4 plus 9, we get the square root of 13. Okay? Then, if I do the next one, I have negative 6 squared, negative 9 squared, but when we square it, I still have 36 plus 81, which is also 117. When I put this in my lovely calculator, I do not get 1. Do not get 1. This is not equal to 1. So in this case, I'm going to get neither. And I don't even care about what the number is. I care that it is not a 1 or a negative 1. Okay? So, last one for this section. Okay, let's look at this one. Dot U, V dot W. Negative 2 times negative 6 plus 3 times negative 4. I get positive 12 minus 12. I get 0. My dot product is 0. So my vectors are orthogonal, which remember it just means perpendicular. Okay, number 1 is asking about the absolute value of complex numbers. So in this case, I is the square root of negative 1. So the absolute value of this is the real part, imaginary part is a squared plus b squared and the square root of that. So a was 2 plus 2i. So in this case, we're going to take the 2, square it, and take the square root of that. I got 4 plus 4, and my absolute value will be the square root of 8. For letter B, I got 1 plus I square root of 3. Okay, so in this case, I'm going to do 1 squared plus the square root of 3 squared. So square root of 3 squared, it cancels. So I get the square root of 4, which would just be 2. Okay. This next one, I got 2 square root of 3 squared plus negative 2 squared. Okay, I gotta square the 2 and the square root. So I got 4 times 3 plus 4. So then I got 12 plus 4 is the square root of 16, which would just be 4. Number 10 says to perform the operation of a complex numbers. Super easy, you just combine like terms. 1 plus 3, I'm going to say the answer 4. Negative 2 plus 5 will be 3i. In this case, though, we got to distribute the negative first. So I got negative 1 plus 2i. And so then 2 minus 1 will be 1. 3 plus 2 will be 5i. And that is it.